Meow 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 meow.
Hello and welcome to a video. My name is Alex, or Poetaster on the internet, and in this episode of the Super Circuit Bending Super Show, we're going to finish up our REX50 bend, and at the end of it, we're going to play around with it and demo some sounds as well. For those who might be new, the Super Circuit Bending Super Show is a series where I show the full process of circuit bending, which will hopefully make it easier for folks who are interested in trying things out themselves. Hopefully that makes it a little bit more approachable. In the first part of this episode, we looked around and figured out what bends we were going to do. In the second part, we created our setup and got all our controls placed and all of that figured out. And in this third part, the last thing we have to do is just wire it all up. So the first thing we're going to do, you can see I have the shell here, and I have the metal frame inside that's been cut away to access the controls. And one thing I did do off camera, I just didn't think about it and realized I should have shot that. But this metal edge here, I didn't want to trim it back any further, but there's not a whole lot of clearance between these contacts and this metal here. So I just put a piece of electrical tape over it to provide some insulation, and that way we don't accidentally short any of the signal connections to the ground of the chassis. So you may recall from part 1, there are these little plastic clips that basically secure the metal shell to the lid until it gets kind of all sandwiched together and held together by screws, which do the primary work of holding these in. Most of those clips broke away. I think I've still got one intact somewhere, but the rest of them are pretty much gone. So just to give this something to stick to while we're working on it, I'm going to use just a bit of hot glue in some of these corners to take the place of that clip. As you can see, this was my surviving clip, and you could hear it pop into place. But since that's the only one I've got, I'm just going to add a bit of hot glue in some of these corners and odd spots to help hold the shell on. Now, I don't mind using hot glue here because it's not structural or anything like that. That's like a good spot. And for anyone who's curious, this is just regular old hot glue. It just happens to be black. It's not any sort of special hot glue or anything like that. Yeah, I'm just taking a peek to see if there's anywhere else I'd like to add some. I think that will do the trick. So I'm just going to clear up all these little stringy guys while that hardens up. For those who aren't already familiar, hot glue is a great thing to have on hand for anyone doing circuit bending or electronics work. It's easy to work with, it's an insulator, and if you happen to screw something up, like if I realized, oh no, I did this all wrong, all you have to do is put a tiny bit of isopropyl alcohol on it, and it will pop right off. So it's great because it can be used as even like a temporary adhesive almost. And for bits like this where something got strung a bit too close to these buttons that need to be able to move, it's very easy to just kind of peel and cut it away. Perfect. I'm going to let that cool and go grab our circuit board. So here's our circuit board. As a refresher, we already connected our power and ground wires. This is when we were testing out our clock mod in part 1. We also connected a couple of lead wires here where the clock used to be. I'll have to go back and look. I believe it's... I'll go back and look, because now I can't recall whether it's which one of these contacts needs to stay permanently fixed and which one needs to be switched back and forth. Now the other thing I'm going to do, in addition to attaching our connection points, is I'm going to install a battery holder with system battery. This one is probably due to die pretty soon since it's been, 30 years. And by adding a battery holder, that just means in another 30 years or so, changing the battery will be super easy because you won't need to do any desoldering or anything like that. So I'm firing up the desoldering gun. So you can see here I've marked the positive and negative contact points that I need to remove. Alright, that should be heated up enough. Alright. Pour it over. And just as a refresher, there's a bunch of high voltage stuff here since this unit is AC powered. However, it's not connected at all right now and hasn't been for about a week, so that's why I am feeling comfortable wrestling around right next to that. So that tab actually just broke off in there. It was not what I was expecting. Get the soldering gun back on. Okay, and I think that has both the contact holes clear. So it looks like it's not going to quite fit into the same footprint. I'm just going to use a short bit of wire for the positive side, and then the negative side we'll put into the board to give it some stability. If you missed part 2, you definitely missed me drilling holes in my soldering mat on accident. Just why this thing is all shredded up. I just realized y'all didn't see that. But basically I just hooked a little bit of wire around this contact point, and now I'm going to solder it in place. Here comes the fan. That wire is soldered in place. Now I'm just going to trim the top of this little contact pin off to make sure it doesn't get in the way later. So next, what I'm going to do, because I find it easier, at least with my goofy hand, I strip off kind of a lot of wire, like way more than you need. I just find that easier to work with. Go. Perfect. So I've just fed that wire through and then bent it backwards. Now we're just going to get that one soldered up as well. Here comes the fan. I'll just clean up this wire end. just working this battery holder into that negative connector. Since we have our wire in place now, I can put it in at this angle where it will actually fit, stay out of the way of everything else. And we'll just tuck that wire away later. It's not quite making it through, it's about flush, but I think that will still work. Here comes the fan. Now, because it's only held in with one pin, it's a little wobbly. That, I think, is where our glue gun is going to come in handy again. Once the glue gun finishes heating up, basically what I'm going to do is try to put some glue in this area here. There's no contacts or anything like that, and that will add some structural stability around the back. Alright, glue gun is heated up, so here we go. I'm just going to hold that down a bit while it cools. So I'm going to let that cool completely, and then I'll come back, and the next step, we are going to connect all of our signal wires to the memory. It should be this chip right here is the one we're going to hijack. Alright, it is now the next day, and we are ready to get bending. So the first thing I'm going to do is connect our ribbon cable with all of our patchbay wires. Just as a quick refresher before we get going, we are going to be soldering those to this second chip up because it had one interesting pin that the others did not. So from part one, way back when, we mapped out all of these bend points. So the ground wire and this loop point, those are the only two that we want to kind of give their own specific connection, if you will. And the ground, we're gonna, we've already got that connected here with this black wire. So really we just need to connect up the loop as well as the other 12. So I'm gonna have that off to the side to help me double check as I go to remember which pins to solder to. Other thing you can do, and I'll do it here to demonstrate, is just use a paint marker or something. This is a good chance to try out a new paint marker I got recently. It might be a little too big, actually. We'll find out. So this is a little bit too big, but does do the trick as far as marking goes. Alright, I think I've got some 15 wire ribbon here, which is pretty much perfect. Ribbon cable is something that I should use more often because it's really great for making things tidy. I'm using it here just because it makes it easy to put a lot of wires really close to each other, especially in an area like the bottom of a board where you don't have a huge amount of clearance. The idea is we're going to run these here, and then we're going to run the cable around the bottom of the board up to the top and connect to our controls. So I don't think this is a terribly cramped project, so I'm just gonna cut a decent length. That way we will have plenty to work with. It is much easier to make wires shorter than longer, so scooch this up for a bit. And I'm not sure if I've mentioned it this video, but if you're new, just so you know, this hand kind of wobbles around due to a stroke, and I wear a glove to kind of help stabilize it. So that's what's up with this thing. But odds are you're going to see a lot of that in this video, so figured I'd explain that in case you weren't already aware. And I've just split the ends here, so now I can kind of start to separate these out. And that's all there is to it. You just kind of snip in between. I did not do a good job with this one. And then pull them apart. What's really easy to do, as I've done here, is I didn't exactly split them. I more cut into the yellow insulation. And it looks like I've done that with several of these. Alright, so here we've got our 8 wires for our top row. And for bottom row, we just need 5. Alright, and there is our 5. Now what I could do is just peel this wire off, or I could leave it on just in case I want to make additional connections later. But actually, if I want to make additional connections, I'll bodge those in. So I'm going to go ahead and peel this down. And just set the side with 5 wires. I've just trimmed a bit shorter so it'll fit more neatly. I hope if y'all could see what I was doing. Where I can put the 5 wires here on the bottom and then kind of come over the top with the 8 longer wires. And now I'm just going to strip the ends off of these 5. Sorry for doing this off camera. My shaky hand is really bad today, so I'm just kind of bracing it up against myself. Okay, we'll see if that's close enough. Cut that down in post, because that was being really stubborn. Alright, let's get our first point soldered down. Here comes the fan. Alright. So not my prettiest work, but I think that's made a good connection. It's coming a little closer to this other ground connection than I would normally like. But I don't think there's any contact happening. There's not really much of a way to make soldering the next 12 of these any more entertaining, so I'm just going to do these quietly and kind of do this as like a speed up montage kind of thing, I think. Anyway, here comes the fan. so that's the first 5 done. Now I'm going to quickly jot down and add to our notes that the gray wire is going to be our loop point. None of the other wires, I mean, they don't matter or anything, it doesn't necessarily matter which jack we hook them up to. The loop point is the only one that's labeled. Well, the loop point and the ground, but the ground isn't coming from this ribbon cable, so just the loop point. So that's really the only one we need to worry about. Alrighty, now next I'm gonna strip all of these other wires and we'll get those soldered in as well. And again, I'll probably time lapse and do some cuts with this because again, nothing particularly exciting or interesting to add here. That went pretty well, I think. I was trying to keep an eye as I went to make sure I didn't have any crossed connections. I'm going to clean this puddle up and just make sure everything looks good. Taking a peek down here. I just want to make sure I didn't get the blue and green wires crossed. It seems like there's a space there, but I'm just going to check it while we're here. Okay, perfect. And I'm just checking using a meter in continuity mode. Basically, it should beep to let me know if the 2 points I'm touching with this are connected. Perfect. Oof. Well, after that, I need a break. So I'm gonna break here and then come back. And when I get back, we are gonna wire up the clock next. Next up, we are just going to solder the original clock back in. Now this upper connection, I keep saying upper, but really the connection towards the back of the device, the jacks, it is going to be the one that we attach to our switch to swap between this internal clock and our clock mod. So we're just going to solder it onto this front connection. Previously I had wired some test leads into here that I could clip onto easily, and I'm actually just going to use those as solder points. It won't look very pretty, but it will work. Claws in the way a little bit, but that's alright. Here comes the fan. It just occurred to me, I might not have much clearance on this part of the I almost call it a keyboard, on this part of the device, so that's why I am flattening it out like that. And I'm just going to give it a quick test fit. I'm going to kind of bend it up this way, since it looks like that's a bit more clearance. That seems to work nicely. Before I kind of bend that finally into place, the last thing I'm gonna do is just attach a couple of wires here. And these are what we will use to connect to our clock mod switch. For no particular reason, other than I just decided it right now, we're gonna use yellow for our signal wire, where we send the clock output, whether it be the original clock or the modded clock. And we're gonna use the green wire for our original clock pin. Perfect. All right, now I'm gonna get those soldered in. Here comes the fan. I'll get these cleaned up. And that was funny, I had totally forgotten that the legs on this, quote unquote, were just little component ends that I had soldered on. So when that one flew off, it took me completely by surprise, but that's what happened there. The last thing I'm going to do, just because this is so fiddly, is I'm just going to put a blob of hot glue probably right around here, just to help secure it in place and add a little bit of insulation in there. Make sure we don't cross any clock connections. So what I'm going to do, I'm just going to strip off the ends of the yellow and green wires and wind them together and just make sure the device boots properly. That'll be just a good quick and dirty test to make sure. All right, so that test looks like it's working. I just wanted to check that before I went ahead and put any hot glue on here. If it turns out later I made a mistake, not the end of the world. Hot glue comes off really easily with a bit of isopropyl. Okay, so the hot glue has cured, and I think our clock should be looking good. The next thing I'm gonna do is just kind of figure out where I'm gonna put our various mod boards. Most of these are pretty small, but it's good to have a game plan before we get too far along running wires. First up, this is hopefully one we'll be seeing more of, which is the new version of my LFO board. Been working on trying to get a nice stable version out there that I can put up on the website for sale. And not to jinx it, I think this might be the one, but we will find out. This is kind of its first test run, if you will. I think this will fit nicely here. Just looking at where things line up. The Vactrol edges should kind of go out over this lower area near where the clock is, and these will be trimmed way down anyway. I just wanted to make sure they had the vertical clearance here, as well as this guy, who should end up right around here. Should be plenty. Next up, I think we've got room at the top. I don't want to get too close to the back because then it might end up interfering with this ridge here and grounding to the case. But if we go a little closer to the patch bay, I think we will be fine. I'm just checking. Yep, the clearance looks good there. I need to bend these guys down. Oh, shoot, I'll have to redo that. I accidentally just broke the resistor off, but that will need to be folded flat anyway. I think we can do these along this upper area. So what I'm gonna do is just put down a little bit of electrical tape as insulation. So that'll provide a nice insulated base. The hot glue I'm going to be using to secure them will also be an insulator, but I always like having something other than just a bare metal underneath the glue. Which reminds me I should do this area now. And this doesn't have to be super smooth or pretty. I'm just smushing it down to make sure it's gonna stick really well. Now I've got where my boards are gonna go figured out, and we've got those areas insulated. The first one we're gonna do is our little power board. And I think I talked more about this in the first episode when we did the music. The idea of this is it's just a little bit of strip board with a couple of capacitors on here. One's a small film capacitor and one's a big electrolytic. And the idea here is that creates a nice power filter to give nice smooth voltage to basically whatever we connect this board to. This is something simple I like to cook up when I'm going to be running multiple mods, because it just makes things a little bit cleaner. What I'm going to do here is just trim these wire ends. And then I like to peel off kind of a lot of insulation. I feel like it makes things easier. Alright, so we're going to use this striped part of the bus here. Negative.
Hours later.
Rather than wrestling that, I'm going to go one at a time. So get this soldered on. Here comes the fan. Just giving it a really careful look to make sure I don't have any little leftover wire strands. So you don't want something coming along and shorting that out. Now, coming off of this power board, we're gonna need 3 ground wires. That's 1 for our patchbay ground point, 1 for our clock mod board, and then the other one will be for our LFO board. Right, get these soldered in. Here comes the fan. Now the last thing we need for this one is just a couple lengths of positive wire. And those should be plenty long, but I'm doing one a bit longer and one a bit shorter. Okay, to get those two soldered in, so here comes the fan. So now the power board is done, I can move the main board away for a little bit, since pretty much everything we're going to be doing will be on the upper portion. Next, I'm going to go ahead and glue down the power board. I'm going to set it right here. The insulated area we created earlier. That'll leave plenty of room here for our clock mod. I don't know how much crying cat sounds are being picked up by my mic, but just in case they are, that is Uncle Dwayne. He's fine. So we've got our power board fixed into place. Next, we need to attach our LFO as well as our clock boards and get those hooked up. And then I was debating on whether I should do it first or last, but I think I'm gonna hook up the big ribbon cable with all the patch bay points last. That'll just make it easier to get to all these control points, I think. So for no particular reason, I am going to start with the clock mod. Off camera, I repaired where I had accidentally broken off one of the resistors. So it is now back to the way it was before, just laid a bit flatter. Since this is going to be right by the power board, I'm going to use the shortest power and ground cables I have, these two right here. I'm gonna get those soldered into place. Here comes the fan. Next up, I just need the wires for the output. as well as the 2 resistance connections. The first thing I'm going to do is put 2 wires in one of the resistance connections. And the reason for that is this will need to connect to both the Vactrol and our manual potentiometer control. So connecting it with 2 wires here is just a little bit easier than trying to solder them, both of them onto a potentiometer or something like that. I think it's easier anyway. And here comes the fan. Now we just need to hook up the other resistance connection. This green wire. As well as our clock output, which I'm going to use a yellow wire for. Here comes the fan. Next, we're just going to start hooking these things up. Starting off with one of our white wires. Gonna connect it here to the manual clock control. I'm gonna leave the other one unconnected for now. I want to do the Vactrols towards the end so that I have the flexibility to move the LFO board around while I'm wiring it up. Next up is our green wire, which connects to the common point on our switch to toggle between manual and LFO for the resistance. Now I forgot that I still had some ends on the bottom of this switch, so what I'm going to try to do is use the desoldering gun to pull that solder off, just because I have an easier time if I can access the little holes and just sneak wires through there. However, if it doesn't work, I'll just try to rig up something with my little third-hand grabbers that'll let me just stick the wire to the outside.
3 days later.
And see if I can get away with just doing a little lasso, kind of like I do on the potentiometers. Okay. That worked surprisingly well. Nice. And I forgot something, so I'm gonna get these 2 soldered in place. Here comes the fan. And the thing that I couldn't remember is when I labeled these switches, whether I labeled where the wire goes or the switch position. And it's the switch position that I labeled. So what I mean by that is I have, actually I now notice it's really difficult to see on the camera. This one's probably the easiest. So here where it says LFO, or the top, that means when the switch is flipped up, it'll be the LFO. But because of how toggle switches work, when it's flipped up, it's actually going to connect this bottom one. So that means my LFO wire goes on the bottom, so that when the switch is up, it connects to the LFO. So that is something I always try to double check on because it's super confusing. So over here where we have mod and internal for the clock. Mod is on top when it's flipped up. That means I'm going to connect the mod output wire. Here comes the fan. I think I've mentioned it in other videos, but it kind of bears repeating with these super cheap little toggle switches. It is good to go fast. Because while they work just fine as far as being switches go, they are really sensitive. If you overheat one of these connection points, it'll melt into the plastic. It won't connect to the lever well, and you can kind of end up kind of melting the whole thing. So I just try to be really quick when I'm soldering onto those. Okay, so with that, our clock mod should be connected. I'm not going to put it in place with the hot glue just yet, just because that's going to create some interference right over here. So before I do that, I'm going to go ahead and connect up our patch bay controls. So just to recap, I've gotten the controls for our patch bay all wired up. I've gotten our power block here all wired up. And I've gotten the clock mod board wired up. So I've got the hot glue gun heating right now. And next, I'm just going to go ahead and fix our clock mod board in place on this little insulated area I created. And once that's done, we will be ready to go ahead and hook up the LFO board. And once we wire in the LFO board, we'll just need to connect the wires we have coming out of the REX50 itself. Got a bunch of wires for our patch bay, as well as the wires for the onboard clock. Once that's done, we are ready to rock and roll. And while I am waiting for the glue gun, now is a good as time as any to announce that in the last video I lied. I was gonna have an alternate one of these ready to go up for sale alongside this one when this video comes out. However, due to life being life, I just haven't had time to make the second one yet. I'm still going to make it, and I'm still going to list it for sale, so follow along on YouTube. If you haven't subscribed already, please do. Wink, wink, hint, hint. Also, my Instagram is the other place where I announce stuff all the time, so if you don't follow me on there, there's a link in my in the description of all my videos, actually, to a link tree that has all my socials and junk in there. So if you are interested in that other one, definitely follow the channel and follow me on Instagram. That way when I get it done, you'll have a heads up. But this one should be up for sale. I'm going to try to time it so that it's up for sale about an hour after this video comes out. And that way folks can have a chance to watch the video and grab it if they're just finding out about it from this. So I'll update the description to have a link to that as well. And just on the note of following things, now is a good time to mention, I really appreciate everyone who does like the videos and has subscribed to the channel. It's a huge, huge help, both in getting YouTube to recommend these videos to other people, which I think is the main way that folks end up watching these, as well as, it's just really encouraging for me to see. So genuinely appreciate everyone who has already done that. And if you haven't, that's totally fine, but it is a free way to help out the channel a whole lot. So if you like this sort of thing, definitely consider giving it a like and a subscribe. Just saying, there's a reason everyone says that. Alright. Down just a dollop of glue here. So I should keep that pretty well locked into place. Right. And the last one of our boards is our LFO board here. So the things we need to wire up to this board are wires for our 2 potentiometers that adjust the rate and the depth. We need wires for our signal indicator LED that'll connect up to this LED on the front panel. Then we need 3 wires that will connect to our wave select switch. And then once all those wires are connected, we just have to hook up the power. Then we can glue this one down and secure all those wires to their respective controls. So I'm just going to use green and yellow wires for our potentiometers. I'm going to use... So I'll use yellow for rate and green for depth for no real reason, honestly. And with these, I'm not differentiating between the 2 wires because we're just putting resistance between these 2 points. It really doesn't matter which one is which. So making both the wires yellow versus one color and one the other doesn't really matter. A lot of times I'll do it anyway just because I'm used to using 2 different colors when 2 different wires go to the same thing. But here I'm just going to use different colors for different potentiometers. I think that will be easier. So last night I was having some weird technical issues with my camera, so that really ate into my filming time that I had for this video. And in the interest of keeping things interesting, what I decided to do was just go ahead and knock out some of the boring stuff off camera. Not that I think anyone would mind, but since the whole premise of the Super Circuit Bending Super Show is to show the entire process, I do think it's important to be super transparent about what happens between cuts, if anything, and open that up for questions and things like that. One of the benefits of being a super tiny channel is I do get to see all the comments and have a chance to reply to them. So if you all ever have questions about something that happens between a cut or the specifics of a process I did off camera, please feel free to ask in the comments. I'm happy to fill you in. But in this particular case, what I did, I went ahead and connected all our ribbon cable connections to the patch bay. I also connected all the wires to our LFO mod board and went ahead and glued it down so it's secured in place. So the last thing we have to do really is just connect all the various wires to controls, and then we should be just about set. I do want to point out on the patch bay is this ground wire is coming from our power distro board. We talked a little bit about this, but because this point is just a ground point, I didn't bother running it through our ribbon cable. Instead, I just utilized our kind of power distribution board to make that ground connection. So the first thing I'm going to do is hook up our LFO. I'm just separating out these Vactrol contacts to make sure they're not crossing in there. And so the connections for this Vactrol, remember we wired 2 wires to the same point on our clock board for our first resistance point. And one of those is attached to the pot, and the other one is going to be attached to one leg of the Vactrol. And it doesn't really matter which leg of the Vactrol, since this is just a resistance between 2 points. As is my way, I'm just making a little loop on the end of the wire here. And I'm going to try to sneak this down to the end. Not for any particular reason other than the shorter we can trim these leads, the easier it is to make sure they don't short out on anything. So I think that will be a good spot for that one. I think I'm going to try to go ahead and wire up the other end of this lead as well. I'm just going to use a bit of green wire. It's funny because I'm not sure how much of this my mic is going to pick up and how much I'll be able to clean up in post, but it is garbage day in my neighborhood, so you may hear a lot of trucks going around. So when it's switched up, this switch is going to put it into LFO mode. So that means the bottom contact is what we need to connect to our LFO Vactrol. Perfect. Now I'm just going to get those soldered into place. Here comes the fan. Next up, we have our really low resistance Vactrol. For this guy, I'm just going to use blue wire for no real reason. I'll go ahead and solder these in. Here comes the fan. I'm actually going to do this one in 2 stages. I'll solder in the first part, then loop on the second part and solder it in. Here comes the fan. One thing that doesn't get talked about too much, but I think is worth mentioning here, is how messy this stuff gets. As you see me go, you'll see all sorts of little bits and bobs get trapped inside the shell here. For instance, this guy. And yeah, really the only important thing with that is that, you know, mess happens. No big deal. But when it is, you know, even these tiny, tiny, tiny pieces of metal, you do want to get those out of there. Just because once you start moving this thing around, what you don't want is loose little flakes of metal creating shorts, or yeah, basically just creating shorts. So I think it's important to show the reality of, you know, things get super messy as you work, and that's fine. But part of that reality is also paying really close attention to, you know, where these little metal shards end up and making sure you clean them up. All right. so next up, we just need to connect our LFO controls. Let's do our switch first. I'm gonna connect to yellow, which is our common first. Good. Next, we have our green wire, which is for our saw. Try to keep things at least moderately sane. I'm just wrapping it around a couple of times. Last one here, this is for our reverse saw wave. I'm just double checking that I've got these going to the right switch contacts. Perfect. And I'm going to get these soldered in now. Here comes the fan. Actually, I was triple checking, and I'm glad I did. I thought this green wire was my saw connection, but it is actually my common connection. And yellow is the saw. I'm just going to get these swapped around. Okay, there we go. Triple checking. Yeah, so green is my common, yellow is my saw. So when it's flipped up, it will be in saw. And white is reverse saw, so when it's flipped down, it will connect the reverse saw. Okay, here we go for real this time. Here comes the fan. That has our waveform switch all hooked up, and next up, kind of hidden right behind this ribbon cable for you all. Next up we have our 50K pot. That is for depth. And this one, it doesn't really matter which pin the wires go to, as long as it's these two pins here. That way as we turn the knob up, it's reducing the resistance, meaning it's making the depth higher. It would still work if we hooked it up the other way around. The control just wouldn't make as much sense, because people are used to clockwise being up. So it would feel really weird if you hooked it up the other way around. I'm just going to do these one at a time, because they're being a little bit finicky. Here comes the fan. Next up, I've just got the rate control, which is our 100K pot over here. Same thing as before. We don't really need to worry about what wire connects to what pin, just so long as we use these two pins. I'm actually snipping the pin off of that one, because there's not a huge amount of clearance between that and the shell. I don't want to accidentally ground it out. anyways, I'm gonna learn my lesson and go one at a time. Here comes the fan. So we've got our rate and depth pots connected. Got our wave selector connected. Got both our Vactrols connected. The last thing we need to hook up for our LFO board is the signal LED right here. And this should be the positive end because it's longer. Maybe hard to see on camera, but it's a little easier to see in real life. And here comes the fan. Just double checking that should be our LFO board all set up. The last thing we need to do is finish connecting our manual clock control pod. So this switch here, when it's flipped down, we want to use this potentiometer. So we just need to run a wire from this pin to here. Alright, and I'm going to go one at a time, but basically I'm going to connect this pot pin to this switch. That way we can toggle between using this potentiometer or using this Vactrol that we connected earlier to control the clock mod. And here comes the fan. The last thing we need to do is connect our wires coming from the original clock source on the board to our toggle switch here. I think yellow will be the common point and green is the original clock. But I'm going to take a break and go look at the original footage just to make sure, since I forgot to write that down. So, okay. Checked the footage and I was right, which sometimes happens. So green is the original clock connection. Yellow is the modded, or yellow is the common point. Here comes the fan. Everything is connected in our little rat's nest here. Last thing I'm going to do is put a little bit of tape around the ends of these Vactrols. That will just stop things from shorting out on accident, since they're hovering right over a metal plate, and will also have the added benefit of trying to prevent any light from leaking in. One piece of tape. I'm just gonna sneak underneath here. That done, I think we are ready for a quick test. So I'm gonna grab an audio source and let's give this thing a try. Oh my god, was I not wearing my mic the whole time? So time for our little moment of truth moment. See if this fires up. I'm gonna change the controls to boot up on the internal clock. There we go. And we're getting a low battery warning because, well, there is no battery, so that makes sense. Okay, so those are all very good signs. Our LFO is running, our device is booting up, and next, I've got a Meowsic hooked up to this. Now, we're gonna turn off the bypass. Okay, so we know something is up with the clock mod, so we'll check out all those connections. And next, let's test out some of our patch points. So first up, let's try out our little ground thing.
The little kitty forgot how to meow. All the kitty say
I'm back with the REX50 after some head scratching and a little bit of off-camera troubleshooting. I think I know what to do, and we're gonna find out. So just to recap what I did off-camera, basically when we tested this out, the clock mod wasn't working correctly. And also, when I connected 2 points to my LFO points from the patch bay, it wasn't really very interesting. It wasn't very good. So there's 2 fixes. I'll start with the easier one, which is the LFO is working correctly. When I measured the resistance between these 2 points, I saw that it was fluctuating. Basically, the only issue here is that these signals that are going to the patch bay are so, so low voltage that the current resistance here is just too high. So I need to bring the resistance of this Vactrol down. This one here with the blue wires. So I ordered some very low resistance, basically the lowest resistance LDR that I could find, and we're gonna try to swap that out and see what that looks like. Now for the clock mod, this one was a lot more complicated, and frankly I'm still scratching my head, but I think I have an idea. So I was going through and testing all the controls, everything was looking good, until I came to this switch. This is the switch that swaps between the internal clock coming off this green wire or our clock mod coming in off this lower yellow wire. And those both connect to this other yellow wire, which take it back to the board. And basically, I noticed this connection was really weird and flimsy. And if I take a continuity reading, you can see resistances are kind of jumping around while I'm just holding this connection here. And I believe I was getting the same thing. Okay, so that is what we would like more expect to see. And of course, now that I'm doing this on camera, it seems to be working a lot better. So I'm actually going to switch gears and give this a little test. So here I've just used an alligator clip to directly connect what's coming off of our clock mod to the board. So let's give that a quick try, see what happens. That has me satisfied that the switch is our problem, because that was working as expected. The one thing I was checking at the end there, I think our trim resistor might just be a smudge too low, because we went with something like 8K, I want to say. It was something kind of an odd value, which is why I ended up using 2 resistors here. So when this gets down to about 500 ohms, that's when things start to get a little hairy. So what I'm going to do, I'm going to replace this switch, and I'm also going to change this out for just a 10K resistor. Well, I'm at it. And I'm going to do this in a kind of janky isn't the right word. It'll work really well. Not a very pretty way, I should say, but it's all closed up, so no worries there. But basically, I've clipped those resistor leads, and next I'm just going to use those same leads to tack on our new resistor. So I'm just gonna get this guy soldered in. Here comes the fan. clean up these ends a bit. Next up, pull this switch. Right, there we go. Move some things out of the way. Not sure how I've already made a massive mess, but I have done it. So I have my replacement switch here. I tested it off camera just to make sure I didn't have really bad luck. I have 2 bad switches in a row. This little socket thing I'm using, if you've not seen me use it before, it's basically just a 3D printed little socket. So it's not particularly strong. It can be prone to slipping. But it's really nice to use when you've already painted a surface and don't want to worry about marring it. I just realized I put that nut on upside down. That's gonna bug me if I don't fix it. So if you don't know, a lot of nuts actually have a right and a wrong side to go up. The side that goes up will be slightly rounded off. Right. So I've got those 3 in there. And I'm gonna get those soldered up. So here comes the fan. And I've probably said this a bunch of times in this video, but I was moving quickly there because these cheap switches can burn out if you put too much heat on the contacts. And a lot of times it's fixable, but better just to move quickly and not have to deal with that headache. So with that, I think we are ready for another test. Grab my headphones here. Looks like we are running on the internal clock. I'm not sure why that's working one way when I set it up with the clips and a completely different way when I have it hooked up to a switch. This is very weird because it sounded like it was working as I would expect for just a second there. Then it started acting weird again. I am extremely confused as to why this is happening. So I think just just to see if it gives us any idea. I'm gonna remove the green wire to see if it acts any differently.
Weeks later.
Bizarre, but I wonder if this green wire is acting like some sort of antenna on the clock, because as soon as I touched this, it stopped. Okay, so I think that is the problem. At long last, we figured it out. That green wire was basically acting like an antenna, and that was kind of jacking up the clock signal and doing all sorts of weird stuff. So the next thing I want to try is to see if I can use shielded wire to connect the original clock source to the switch. And if I can, then I think we will be up and running. Prefer not to do a drastic change at this point, but worst case scenario, if I do have to make a drastic change, I can essentially remove this control and leave it so that the clock is always modded. I'd prefer not to do that, A, because I don't want to change things this late in the game, and B, because I prefer just having a switch versus having to have the user adjust the manual knob to a certain position to be able to edit or modify things. I think I've talked about shielded wire before, but in case you're not familiar, basically inside this wire, we're gonna have two signal wires, a white and a red, surrounded by this kind of strandy stuff. That stranded stuff is the shield. gonna get this guy soldered in. Here comes the fan. My camera is starting to get really warm, but I do want to see if I can get in a quick test before it goes. Okay, so I've replaced this bottom panel. As you can see, I've eliminated the switch to swap between the internal and modded clock. Now it always just runs off that modded clock. So the next thing I want to do is try to fine-tune the LFO ports for patching. I went ahead and redid the Vactrol that controls the resistance between these 2 points. However, it's still a little bit high. So first I'll demonstrate that, and then we'll take a look and see if it's something we can work through. So you can see this is what that patch does when we have it attached to the potentiometer. It's only at a very low resistance does it start to have that weird effect. So this is a good test patch for the LFO points, because I know it responds well to having some resistance adjustment on it. But now when I plug it into these ports, you can hear we're not really getting anything. So what I've done, I've set up these 2 clips to these 2 points. And what I'm going to do is try attaching resistors in parallel to see if we can reduce that resistance at the peak of the LFO at least, to kind of have some effect on these very, very low voltage signals. Now, I'm not super smart about this stuff, but the formula for resistors in parallel, I don't know it offhand. I usually use calculators online if I need to figure it out. But in this case, I'm kind of just winging it and setting it up this way. You know, trial and error is easier for me than math, but if you are more clever than me, you can use those calculators, do the math to figure out exactly what resistor, if any, would potentially work for this. But for me, I'm going to start out with a 1K resistor in parallel. Try going down to about the 330 ohm range. See if we get anything here. Didn't hear anything too exciting there. I'm gonna move it up to 470. Next, moving on to a 2.2K. Nothing on the 2.2. I'm wondering if I need to go really low potentially. Here I've got 47 ohm. That was really promising. Let's see if going even lower makes it more or less interesting. This is a 33 ohm. So let's keep moving down. This is a 4.7 ohm resistor. We're going from 33 to 4, which is a pretty big jump. Still not getting a huge amount of differentiation. So I'm gonna try jumping up to, let's try 100 ohms. Getting somewhere. So that we could hear an audible difference going along with the pattern. That worked quite well with the 100 ohm. That is what we're going to do. I'll just install that in parallel. Next thing I want to try to mess with, you may be able to see it here, but when I turn the depth up, you see the LED just stays on, and I'm wondering if I can just add a little resistor in line with that potentiometer to fix that. What I'm gonna do to test this out is just put one of my clips on the end of this wire and put the other clip where it was previously connected to the potentiometer here on the middle pin. And to give myself a rough idea, I tried to adjust the resistance to be as low as possible, and it looks like I'm reading right around 600 ohms. That should give me a good starting point. So let's try it out with a 1K resistor. Oh, gnarly voice crack there. Okay, so the 1K resistor seems to work well. One thing I do want to test is just to make sure I'm not dimming the light so much that it's no longer going to work. I would stress, yeah, we don't have a resistor in parallel anymore, so. What I'm going to do, just because it does look slightly dimmer than I'd like, let me see if I can get away with a 470. So both of those, it stops when I've got it cranked to full speed. I honestly kind of like that option where full speed is actually just on. So that's still working at 470. see if we can take it even lower. Alright, here is 330. Alright, 330, we're still good there. I wonder if this is one of those things where you just need like an amount of resistance. So I'm gonna try a drastic jump here and go from 330 down to like 33. This is where if I was smarter with theory, I would probably just know what to do. Okay. Yeah, it seems to be that just any amount of resistance is good. Because yeah, this 33 ohm is looking great. The last one I'm going to try is just with a 10 ohm, since that's a really common value. Okay, so 10 ohms is not enough. So I'm going to add a 33 ohm resistor in line with my depth knob. And in the next revision of my LFO board, I'm going to include that on the board itself. And I'm also going to add that 100 ohm resistor in parallel with my Vactrol here. And this thing should be ready to go. So I'm going to get that done, get this thing put back together, and then we'll have some fun playing around with it. So we have now reached the fun part of the video where we get to play around, but just a little bit of housekeeping before we jump into this thing. So first up, here it is, put back together with all the knobs put in place and the requisite stickers put on. Now the first piece of housekeeping, I mentioned before that I was going to be selling this, and this will be listed on my website, petercatproductions.com. There will be a link in the description, and I'm also eventually going to put together a second variant for this one. I think I mentioned before. My original plan was to have them done at the same time, but I've actually been busy preparing for an exhibition, so I have not had time to put it together yet. So when that one is done, I will be announcing it on my Instagram as well as on the community tab here on YouTube. So if you don't follow me on Instagram or you aren't subscribed to the channel yet, but are interested in grabbing a red and black variant of this REX50, then go ahead and give those a follow, because that'll be the best way to see when it's out. And finally, as always, I do want to thank everyone who likes the videos, subscribes to the channel, and everyone who leaves comments, things like that. It is such a tremendous help for a growing channel. If you haven't done those things and would like to chip in to help this out, those are the best ways to do it, and they are completely free, which is also great. So much appreciation to everyone who's already done that, and a big thank you in advance to anyone who does after this video. Finally, as a more material way to say thank you for that, if anyone is interested in buying this, I'm going to offer a coupon code called iFinish2.3 with an exclamation point. If you punch that into the coupon code on the website, it'll give you 20% off, just for this item, but that should save a pretty good chunk of change. So just put that in as a thank you for watching and subscribing. And yeah, we'll see. I'm new at this thing of making videos and then posting the item online, but I do like the idea of continuing to do that in different ways as a thank you to everyone. So without further ado, I am going to go ahead and fire up the Meowsic I have off camera, and let's see what sort of weird noises we can make with this thing.
Where's our gerbil? I haven't got a clue. Where's our gerbil? Catch the cat before he's through. Uh-oh, the Gorbers too. Uh-oh.
Yeah.